Hi everyone. Today I want to talk about solving quadratic functions by factoring. In this particular video, we're going to solve by factoring when a is 1 and when a is greater than 1. So let's get into it. So we've done a ton of factoring on this channel. A lot actually. Many different ways. Many different times. So in this particular video, with this particular way, we're going to solve these quadratic functions through the factoring process. So really what we're doing is we're just adding one more step to the process of factoring that we already know and we already love. So let's get into it. Example 1. We're going to solve this quadratic function x squared minus 8x plus 16 equals 0. So first you might notice that there's an equals 0 there. You're going to see that more often now because that is a great indicator that we need to solve for x or solve for the variable. So when I have a as 1, I'm going to use the area model. So let's go ahead and do that. And we'll pretend for a second that we're just factoring it. You're going to see how easy this gets. So I'm going to draw my trusty area model squares. X squared goes in the first box. 16 goes in the lower right-hand corner. No changes there. I'm looking for factors of 16 that I could add to a negative 8. Well, I know that 4 and 4 work. So I'm going to take a 4 and a 4. And they both have to be minus signs because I have to add to a negative 8 and multiply to positive 16. So we're going to put negative 4x here, and we're going to put a negative 4x there. Now, take the greatest common factor out, like normal. Both here and here, I've got an x. This is going to be a negative 4. And then because we have the same exact factors, it's actually going to be the same thing, negative 4 and x. And we've got our factors, x minus 4 and x minus 4. But wait. There's more. I need to solve now. We're not just factoring. If we were factoring, this would be the final answer, and we would have already moved on to example 2. But because I need to solve, it means I actually need to solve for the variable, meaning I need to find values that the variable is that makes this equation true. So here's the next step, which is also the last step. Each time we have a parentheses, we are going to set each set of parentheses equal to 0. Here's what I mean. X minus 4 equals 0. Now I'm going to do that again just for the sake of doing it again because we kind of have to, but normally we won't have the same exact factor paired twice. And x minus 4 equals 0. Now I'm solving for both of these variables. I'm going to add 4 to both sides where x is going to be 4. And again, I'm doing the same thing here just so you can see the process. And I have now successfully solved this quadratic equation or quadratic function. X is 4. Now it happens twice, and that's silly. We're going to get into that in a minute. But my answer to solving this quadratic equation is x equals 4. It happens twice. Let's move on. Example 2. Let's area model. I'm trying to solve number 2. Again, let's draw our boxes. X squared, positive 4. I'm looking for factors of 4 that I could use to add to 5. Well, that's going to be easy. It's 4 and 1. And they both have to be plus. So we're going to have a 4x here and a 1x here, or we could just put x there. It's fine. Now we'll take greatest common factors out. X comes out, 1. On the side, it's going to be x and a 4. So we've successfully found our factors. That's going to be an x plus 1 and an x plus 4. Now, next step, which again is our final step, I'm setting both of these equal to 0 individually. So the first factor set, x plus 1 equals 0. And then the next factor set, x plus 4 equals 0. Solving for x, I'm subtracting 1 on both sides for my first one, which is going to give me x equals negative 1. And then I'm subtracting 4 on the other equation. X is going to equal negative 4. And I have found my answers. You can still see that, making sure. X equals negative 1 and x equals negative 4. And those are my solutions to this quadratic. While I'm erasing all of this nonsense, go ahead and try example 3. Okay. I probably could have edited that out, but why bother? Let's see where we're at. Hopefully you got at least almost through the factoring part, because I'm actually fast at erasing. R squared goes in the top corner, 56 goes in the bottom right. I'm looking for factors of 56 that I could add to 15. 8 and 7, hopefully, right? And they both have to be plus because I don't have a minus sign anywhere in sight here. So 8R and 7R. R comes out. 7. R. 8. Okay. So I've got R plus 7 and R plus 8. Again, those are my factors, and if I just asked a factor, we'd be done. But because I'm asking for solving, we have to use the factoring process to get to the solving part. So I'm going to set each one of these equal to 0. And I'm going to solve for R. So R is going to be negative 7. And R is going to equal negative 8. So those are my two answers for number 3, negative 7 and negative 8. All right, let's go ahead and try the last one here. This is actually, it's weird that area model box is protruding into my last question. Okay, hey Titan, this rag is wet. Did you take this rag? The rag's wet, it's not supposed to be wet. It's supposed to be dry. It's gross. Thanks, buddy. That's why it was on the floor. Ew! So he probably took it in his mouth and walked around with it because that's what he does. Hopefully he'll make an appearance later on today. M squared, 28. I'm looking for factors of 28 that add to 11. I need a negative 11, sorry. I need a negative 4 and a negative 7 because I have a negative 11 here in my B term. So I need a negative 4, M, and a negative 7, M. M comes out, negative 7, M, negative 4. Okay, factors are M minus 7, and if I go over here, I'll run out of space. M minus 4, setting them equal to 0, so M minus 7 equals 0. M minus 4 equals 0. Now, the way that you write them, just be careful. It's probably better if you have M equals 7 and M equals 4. But if there's just some way that you're giving the answer, that's fine with me. Right? 7 and 4 would be fine. Just make sure you're doing it right for the teacher. Right? So there we are. Now, all of these are when A was 1, meaning there was no value in the front of the initial term or the term that had the square. The next set of problems, there will be an A is greater than 1. No difference in terms of the factoring process. The only thing that's going to be a big change for us is our answers may have fractions in them. And let's see what I'm talking about. Example 5, 35x squared plus 22x plus 3. Area model all the way. We're not changing anything about how we solve these problems in terms of factoring. So, 35x squared, 3. 35 times 3 is 105. So I'm looking for factors of 105 that can add to 22. Good thing I have a calculator here. I think it's 15 and 7. 15 and 7. Both plus, because again, there's no negative sign anywhere near here. All right. 15x and 7x. Let's take our time here. Greatest common factor of these two is going to be 5x. Greatest common factor here is just 1. Here I'm going to have a 7x, and here is going to be a 3. All right, now our factors are 5x plus 1 and 7x plus 3. Again, just like the first set of problems, I am going to set these equal to 0 and I'm going to solve. Both of these are going to have fractional answers or decimal answers. The fraction is what we want though. So let's do this one step at a time. 5x plus 1 equals 0. I'm always going to subtract first or add first. That's what the reverse of PEMDAS tells us to do. And this is old school algebra 1, right? So I've got 5x equals negative 1. I'm dividing by 5 on both sides, where x is going to equal negative 1 over 5. That is one of my answers. And no, I do not want to make that a decimal. And we'll talk about that in probably the next video of why we don't want to do that. We'll connect this to a graph, but let's move forward. So negative 1/5 is going to be my answer. I think I said 1/2. I hope I didn't. Let's subtract 3 on both sides from this other problem. 7x is going to equal -3. Divide by 7 on both sides. And my other answer is also going to be nasty. It's going to be x equals -3/7, right? So here are my two answers, -1/5 and -3/7. Those are the answers. Now, connecting them to what's happening actually on a graph here is, these are the two x-intercepts of that graph. So if I were to graph this on Desmos, or any graphing mechanism, these 2 points on the x-axis is where they're going to connect, where they're going to cross. So we're now kind of figuring out what this thing will look like on a graph, okay? Let's go to do one more, and then I'll stop and see if you can get the other two on your own. So our last one here, together, 15a squared minus 4, right? So I'm going to do a -60, and I'm trying to get factors of -60 that could add to +4. 10 and 6. But the 10 has to be a positive because I have a +4 result. So we'll do 10a, that is an a, right? Okay, and a -6a. Greatest common factor of these two is 5a, -2. 3a, 2. Okay, so our factors are 5a minus 2 and 3a plus 2. Let me erase this other stuff so we can kind of get to where we're going. And in the meantime, you can go ahead and see if you can get the actual solutions to those two. Okay. So we'll have 5a minus 2 equals 0. Again, we're setting these parentheses equal to 0, right? And then I'll have a 3a plus 2 equals 0. Adding 2 to both sides on the first equation gives me 5a equals 2. Divide by 5 on both sides will give me a equals 2/5, so 2/5. That's my first solution. Subtracting 2 on the second equation gives me 3a equals -2. We'll divide by 3 on both sides, where I'll get a equals -2/3. Again, two solutions, fractions, nasty. But again, all we're doing is taking the factoring process and going one more step to solving these things. And I have our answers there. So go ahead and pause me, see if you can get 7 and 8, and I'll just come back in a second with the answers. All right, everyone, you're back. I know you missed me. For example 7, our answers are going to be b equals 2 and b equals -7/2 with the work. And the red pink marker, it's not as bright as it used to be. That's sad. Example 8, our answers are going to be m equals 3/4 and m equals -5. Let's finish up. Things to remember about this video. Number 1, we're only adding one more thing to the process of what we already know, which is factoring, and that's solving. We're literally just taking each factor set and equaling it to 0 or setting it equal to 0 and solving for the variable. Number 2, when we're done factoring, literally whatever is in that parentheses is what we are making equal to 0, right? So we are trying to find or connect what those values are that make the equation true. Meaning if I threw in or substituted back the values that I get, or the x values that I get, it should equal to 0. And then number 3, please be careful to not skip steps in the process. I've seen this literally a billion times, where some people will skip a step and say, well, it's just a negative sign. Yes and no. So if you think about skipping a step, try to think again. See you next time.